Hello, I'm Nick. I'm a security engineer at Amazon. I have a background in networking and systems engineering. I'm a ham radio operator, so I play with radio stuff all the time. So you can see why I'm kind of interested in Wi-Fi. First, quick question. Who here knows a lot about crypto? Okay, if anybody has any questions about crypto, ask him. I will freely admit that is not my strong point. So I'm not heavy on the crypto details in here of the security protocols. Anyway, that said, let us continue. So Wi-Fi is something that you all use all the time, are microwave in your pockets constantly. Allows you to communicate using the magical power of the ether. And you have to say it like that whenever you talk about Wi-Fi. Wireless communication. It lets you send data back and forth by wiggling electrons on a wire. Started out back in '97 when I suspect most of you weren't even born yet. God, I feel old. Anyway.
2 years old.
Okay, there you go. So we had a measly 2 megabits per second using the 2.4 gigahertz band. A couple years later, bumped up to 11, because, you know, it goes to 11. Then also a 802.11a was developed for the 5 gigahertz band, which gave us 54 megabits per second. There wasn't a lot of 802.11a gear because 5 gigahertz radio equipment was more expensive. So we did get 54 meg per second in 2.4 gigahertz, sorry, I made a typo there. That's supposed to be 2.4. In 2003, basically the same modulation techniques that they used for 802.11a applied in the 2.4 gig band so that you could use the same cheaper radios. Then 802.11n, much faster. I think you can actually get 450 megabits per second out of it, and it operated on either 2.4 or 5 gig. Again, since 2.4 gig is cheaper, that's where most of the gear was. And now we have 802.11ac up to 1.3 gigs per second, and it is only in the 5 gigahertz band. As for what is a gigahertz, just the rate at which you wiggle those electrons on the wire. Wi-Fi is split up into separate channels, 20, 40, 80, or 160 megahertz wide. In the 2.4 gig band, we only have about 70 megahertz of bandwidth. And with a 20 megahertz wide channel, you have only 3 non-overlapping channels. If you want to be a jerk, you can use a 40 megahertz wide channel and step on most of your neighbors. 5 gigahertz has a whole lot more available. So we have 45 channels, 15 of which are completely restriction-free. Some of those are designed for 40 or 80 megahertz wide communication, so you don't have to step on adjacent channels to use them. Some of them, in order to prevent interference with weather radar and things like that, you have to have certain transmit power control and band usage detection. So Wi-Fi itself comes in a few flavors. We have ad hoc, which is what you have when you just tether something to your phone. Simple device-to-device communication. Bridge mode, where you have an AP that's talking to another AP, and it is either just bridging to a wired port, or there's WDS, which is a wireless distribution system, which is sort of a local repeater of the wireless signal. And the most common is infrastructure, where you've got an access point and one or more clients. Access point has an SSID that the clients associate with. And in this mode, even though if you have like 4 or 5 clients and they want to talk to each other, they still go through the access point as a mediator. One of those words. You have a few different frame types. Just management frames, which is the access point telling the client what to do, the client telling the access point what it wants to do. Control frames for just, there's some power control things you can do. Ready to send, clear to send signaling to say, hey, are the airwaves open for me? And I think there's one that lets you monopolize the airwaves for a certain amount of time as well if you have some bulk transfer. And then the data frames themselves that have what you're sending and some QoS traffic and just acknowledgements and such. So you've got your lovely Wi-Fi network up, and then you realize everything is really slow. It turns out your neighbor is using it for all their Netflix. So throw some security on there, because it's just a thing you put on, right? You can do a bunch of things like MAC filtering, which is completely useless. Don't do that. There's some security protocols. We have WEP, which was the original protocol used with long ago, WPA and WPA2. So let's start with WEP. It is called the Wired Equivalent Privacy Protocol. I don't have a very high opinion of that. It's using a 64 or 128-bit key value fed into the RC4 stream cipher. You have a 24-bit initialization vector, and then either a 40 or 104-bit fixed pre-shared key. Let's see, and a CRC32 just checksum on it, and that's pretty much it. You can do open or a handshake authentication when you associate. Problem with the handshake authentication is the access point will send you some random value, and then you encrypt it and send it back. So you've exposed the plain text, and you also send over the initialization vector when you send the return traffic. So now you just have to brute force a 40-bit RC4 key, which doesn't take all that long. Let's see. Oh, yes. 2004 paper, they did a study and found it takes about 6.5 days to brute force it with your average computer back then. So, yeah. So nobody uses that. There are other weaknesses in RC4 and the specific implementation. Since you only have 24-bit IV and you have a busy network, you are going to get collisions. And you don't want that with a stream cipher. So there's this lovely paper that talks about how you can do a key recovery in just minutes. And this was back in 2001. So this is how long this has been completely broken. Don't ever use it, dear God. So then WPA came along because the Wi-Fi Alliance said, wow, we messed that up. It is Wi-Fi protected access, and it kind of fixed things. So they use an encryption system called TKIP, the Temporal Key Integrity Protocol. It does a key mixing instead of a straight concatenation to create a session key. It's basically just a hash of several different values. And then it uses that session key plus an IV into RC4. So the session key gets rotated after a certain interval. And there's also an additional 64-bit integrity check called Michael, because, yeah, it's long for Mike. Message integrity check. Creative. Anyway, so if you have 2 invalid mics within a 60-second interval, it triggers a rotation of the session key. However, some implementations do a timeout of 60 seconds before it rekeys, so you end up with a 60-second outage of your network. Yeah, and the only way, there's a way around that, which is instead of doing your tests against the access point continually, you just do one. If it fails, you wait 60 seconds, do it again. Because there's a way to do a byte-wise brute forcing of the key, especially have something short like an ARP request, where you're pretty sure of what's in there, and you can just do bitewise guesses on it to kind of back out what the key is. The reason they did the session key the way they did is because this is a backwards patch for older access points that were implemented or implementing WEP, and they didn't have very powerful processors, and so doing this hash function to create the session key was very expensive processor-wise. It's not something they could do with every packet. So that's, yes?
What is WPA AES?
Right here, WPA2. So WPA2 was a totally new design from the ground up. Uses the CCMP encryption system, which is the counter cipher mode with blockchaining message authentication code protocol. Say that, even 1 time fast.
They're missing some letters.
Yeah. They're silent. So this makes use of AES in block cipher mode. It uses the password-based key derivation function version 2 to generate the AES key from the private shared key, or the pre-shared key, sorry. So great, that sounds awesome. There's always a but. Somebody decided, it's really hard to type in passwords. What if we just type in a little short number, and then you can do the key exchange using that short number? That's, yeah, excellent. See, we have an 8-digit PIN for WPS, usually printed on the access point, sometimes even derived from the access point's MAC address. So, I can understand why they did it, because you need some way of programmatically burning this in or generating this on the device and knowing what it's going to be on the sticker. But yeah, if you got something predictable, guess what? Somebody's going to predict it. So you have this 8-bit or 8-digit PIN. One of the digits is a checksum digit. Throw that out. We have 7 digits. The way they verify it is in 2 sections. So they chop it up into a 4-digit and a 3-digit section and verify those separately. So now instead of 10 million values that you need to punch through, you only have 11,000. You can brute force this in under 4 hours. This is why we can't have nice things. So let's talk about in large environments. It does not do to go running around putting in a pre-shared key in 10,000 computers, and then one of those computers gets lost and you have to go rekey 9,999 computers. There's a system called 802.1x, which is used for authentication of devices on wired and wireless networks. More commonly wireless. Wired, sometimes older devices have problems with. Yes?
Where'd all the 802s come from?
It has to do with, let's see, 802.blah it's usually an IETF numbering, I think. Or is it IEEE?
I think it's
IEEE? One of those two. Blah, blah, blah. But I don't know exactly. 802.11 is wireless. 802.3 is wired.
Well, there you go.
So IEEE 802 refers to a family of IEEE standards dealing with local area networks. There you go.
There we go.
So it's completely arbitrary.
So there are a number of authentication protocols that can be done using 802.1x. Basically what 802.1x gives you is the framework to communicate between a device, an authenticator, which is usually the switch or access point, and then an authentication server, like a radius box or something on the other end. So we have LEAP, the lightweight extensible authentication protocol. It's using MS-CHAP for its password exchange, which is not so good. Known weaknesses with that, and it's Cisco proprietary, so nobody really uses that anymore. PEEP, the Protected Extensible Authentication Protocol. Also Cisco and Microsoft and somebody else who I didn't write down because I'm silly, did that. And it sets up an encrypted tunnel between the client device and the authenticator using, between the client device and the authentication server using TLS. So all you need is the authentication server to have a public cert on it, and you can set up your session that way, and then do the authentication exchange over that. The authentication exchange within that tunnel is typically MS-CHAP v2, but at least it's wrapped in TLS. We also have EAP-TTLS, which is EAP tunneled TLS. Very similar to PEEP, just same public key authentication to set up your TLS tunnel and then do whatever EAP method you want to within that. And let's see, that one, Windows 7 and earlier does not support it. Linux, of course, you can support it because somebody has written code for all of these, but you know. Yeah. And then a common one is EAP-TTLS, which requires some additional infrastructure. You need a full PKI set up to distribute key materials and certificates to all your clients. But then with that, you have a full bidirectional authentication between the client and the server. So it's nice and actually quite secure. AD is handy for that because it lets you provision certificates on devices. Yeah, nice system.
Fun fact for any of you connected to Secure Mustang Wireless, it uses PEEP with MS-CHAP v1, I think, which is a secure protocol wrapping an insecure protocol. They're both broken.
I thought it was V2.
It's all broken.
Pretty much.
It has MS in it.
So how do we break these? There are a number of cool tools that let you do all kinds of fun stuff on your own networks, of course. Aircrack-ng does, it's everything in the kitchen sink, honestly. It's WEP, WPA, WPA2 does all kinds of cool stuff. DAuth attacks, replay, oh yes. So those management frames we talked about earlier, none of them are encrypted or signed in any way whatsoever. So you can pretend to be the access point and kick somebody off the network. And one of these attacks is to capture the authentication exchange when it re-authenticate or reassociates to the access point. And then you have, hey, look, I can take this and brute force it later using, you know, your average password cracking tool. Yes?
So is that how you can kind of do man-in-the-middle attacks, like basically setting up fake access points?
Yes, sort of. So the fake access point, you can just, pretend to be the access point and somebody associates with you and starts the association exchange, and then you can use part of that. I forget exactly what that attack, or how that attack works. But it's...
Once someone's on your access point, it's pretty much game over because almost everyone's configured to use their access point for DNS.
Yep.
And then suddenly they're trusting who you tell them is google.com or whatever.
Well, the thing with that is when the user goes and associates with your fake access point, you don't have the credentials with which they can properly associate. For WPA2, there's a full two-way exchange for them to connect. So when somebody connects to you, you don't have the passphrase. The association is not going to complete. So you're not going to be able to own their traffic.
Well, what you can do is you can just say, oh yeah, of course I am this network, but you're just running an unencrypted network with the exact same name. And DAuth them, they reassociate to yours, hopefully, rather than theirs.
Some devices that might work, other devices will pop up, hey, I'm connecting to something different and it's got different security credentials, there's different security settings.
Mm-hmm.
So
So the easier and more productive way, if you actually wanted to man in the middle of somebody, is go sit at an airport and stand up a fake AP, an evil twin AP, with the same name as like the airport APs, because there is no auth. By default, Starbucks, all of the above, there's no auth whatsoever. So you sit in the middle. Then, as you said, Max, you own DNS, you own all their communications. It's game over for that
everything. Yep.
Yeah.
Weren't AT&T iPhones set up to associate automatically to ATT Wi-Fi?
Yes.
Yeah. Thanks, guys.
Comcast, I don't know if you guys use Comcast around here, but Comcast, their APs that they will rent you an AP and then let some other people siphon off your bandwidth with a Comcast Wi-Fi network. Basically trying to make a mesh network to cover entire cities. Same idea. There's no authentication on that, so you could stand up an evil twin on that as well and just wander around and pick up credentials all day long.
Yep. So yes, once you've grabbed an exchange, John the Ripper, you can do some brute forcing. It's word list based, so you need a big dictionary file that you can run through it. There's also Hashcat, which uses GPUs for their password cracking. Again, you can use a word list or the built-in rule engine to kind of make an on-the-fly word list as it goes based on just kind of what you want it to do. And then there are other tools like Crunch and some others that will actually generate word lists or take dictionaries and feed the dictionary through the tool, and it will turn everything into leet speak or whatever. So leet speak doesn't help you. Don't use WEP. Don't bother with WPA. Use a long, strong passphrase or random string, except correct horse battery staple, because everybody uses that now. So here's a nice 63-character random string, way easy to type in, right? Or just grab, there are a number of tools like Password QC that will generate a passphrase for you, which is just spits out 4 or 5 dictionary words with variances in capitalization separated by random punctuation characters, and those are reasonably strong. Or if you really want to go crazy, set up your own CA, start signing some certs, and run your own Radius server. Probably overkill, when your family comes to visit and they say, I can't get on your network, and you say, oh, let me just sign some certs for you and get some key materials to you. Yeah, that sounds like a great time. But if you want to, I'm not stopping.
Alex, you got on that?
Will it make my family stop coming for dinner?
No, but if you put a squid proxy on your router and start doing all the upside down images, filters, things like that, that might scare them off. They'll think like your internet is possessed by the devil.
Oh, they already believe that.
Even the Wi-Fi network virus detected as well.
Yep. Oh no! So yes, and there are tons more resources out there. Actually, EAP-TTLS.org, which I had never heard of before, happens to have some really good documentation on WEP, WPA, and WPA2, and CCMP. SANS has an article on 802.11, 802.1x. It's kind of old, but it's still pretty good. Some talks from the DEF CON wireless villages have some good stuff on there. And Aircrack has a ton of really good step-by-step tutorials. And I am on the Twitters. This talk I'm going to stick up in my GitHub repo so everybody can take a look at it. I'll add it as a comment on the YouTube link when you guys get that online. So that is the survey of the Wi-Fis and how they are mostly secure. Any other questions? Yes?
Yeah, did you know about Reaver? Reaver is a tool built into Kali and some other distros that automatically brute forces the pins in WPA2.
WPS.
Or
WPS.
WPS, yeah. That was just interesting that was on your list.
I had not thought of that. Actually, the WPS I thought of last night and added on there
And,
because I turned it off on everything. So
more secure router types, like net years are less vulnerable to WPS attacks than
They'll sleep for 5 minutes
Yeah.
if you try to brute force it.
Japan.
It's-
honestly, anything you can turn WPS off on is going to be the best.
Yeah.
So just don't.
And Reaver can
Don't leave that
scan
open.
for whether or not it's on or off, which is kind of nice.
Mhm.
Of course, none of you can run any of these tools on Secure Mustang Wireless.
Please do not run these tools on Secure Mustang Wireless. Come to the lab.
Only for your own networks, for your own educational purposes, or professional activities as endorsed by your scope of practice.
Can you go back to the slide that has the enterprise app?
What? This one?
Yes.
Wait,
No.
hang on. But
The third to last slide.
no, wait, hang on. Back further or forward?
I don't know.
Which slide?
The one that said,
WPA Enterprise?
yeah,
Oh, okay.
the last one that said that.
Like that one. I think it was 4.
No. Yes? No?
No.
No. Wait. Yeah. What? No. Yes. Yes.
And
One more. One more.
Got it.
Keep in mind, all these slides will be on the video. If you need any further information.
Please don't write down that password because I'm going to go to your house and try it. Anything else? Yes?
Is there any software out there where you can actually set up virtual LAN and set up virtual hosts so we can set up these exploits? So I know they can set up some of these hosts and install Kali Linux on them and run that exploit. So is there any software out there we can use for something like that?
You can set up host APD depending on what wireless device you have. Host APD lets you set up your device as an access point. So you can have an AP running, you can assign it to a VLAN, you can have multiple SSIDs assigned to multiple VLANs, and then just have some client computers on them and start testing against them.
What about things like Cisco Packet Tracer? Can you set something on there too? Like a LAN with a few hosts and servers?
I don't think so because I don't know that it will generate the right frames that you can capture as if you were capturing them off the wire. That's interesting though. I'm not sure.
Something else you can try, Linksys hardware running DDWRT or Tomato. A WRT 54G, you can buy them for $20 these days. They've been around forever and a day. You flash the firmware with DDWRT, and you get a lot more options you get out of the box from Linksys. This is actually an open source issue because what happened was Cisco used open source code in their implementation of their OS on those devices. So they had to open source the entire thing. People then took that, and that's how Tomato, DDWRT, and the rest of the open source firmware came about. So you can use that. It's really cheap. It's very easy to play with, command line interface, as well as a GUI. And that's another way to stand up a bunch of APs. You can stand up multiple SSIDs on a single physical box and play with the stuff too that way.
You can also grab some just cheap USB adapters. There's a TP-Link adapter that's, I want to say it's like $12 on Amazon. It's an 802.11n, 2.4 gig only, but packet injection, everything works on it. It'll act as an access point if you wanted to. Really easy to use. It's one of the recommended ones for Aircrack, and I think Kali suggested as one of their things too.
Can you use an alpha router on that too for packet injection?
A which?
The alpha router?
Mm-mm.
Yeah, it's used for packet injection. It's pretty much used for masking your MAC address, smoothing your MAC address, if no one can call it.
Anything that supports, injection as well as promiscuous mode will work.
Mhm.
Okay.
And most cards do nowadays.
Yeah, this one will work. Yes?
What if you do even max kind of would Airbase allow you to simulate that? Does it have functionality for?
No idea. I haven't used Airbase in a while.
It's okay.
Possibly.
I
think that's- I can find out.
All right. We're good. Thank you all.